Hello. So in this video, I'm going to introduce the different kind of electric material. We can classify the material into with their electric property, like electrically insulating material, electric conductive material. So what does it mean by electrically insulating? Electrical insulator. So insulators, either if the materials are insulators or conductors, they're different. They behave differently electrically, right? Electric insulators are like papers. This is insulators, paper, wood, plastic. If air is very dry, that's an insulator. Ceramic is also an insulator. This inside the insulator material, like inside a paper, all the materials are made of atoms and molecules, right? And atoms, molecules have electrons in it. And electrons in the insulators are bounded to the atoms or molecules. So you have a nucleus here, and then electrons are, bounded around the nucleus or bounded between the molecules that they can't travel farther away. They're in the orbit, they're bounded in it. So insulating material, you do have electrons, but they're just bounded. They can't move around. On the other hand, conductors, metals are conductors. So this is a metal, right? So all the metals like copper, aluminum, steel, they're all conductors. Like right here, right? This is a conductor. I shouldn't be touching it. Electrostatic force. This is a conductor. This is not conductor. This is the insulator. This part is a plastic. So you have an insulator that's protecting it, and then you have a conductive material, the metal. So copper, aluminum, steel, those metals, that shiny material, they are conductive conductors. And the conductors also have atoms and molecules, right? They have electrons, but these electrons in the conductors, they are free to move. So that they're not necessarily bounded to the nucleus or to the atoms, or molecules. They can actually move from one atoms to the another atoms, one molecules to the another molecules. Just like imagine that you have a fluid inside, fluid of electrons, which is they're called free electrons. So conductors have a free electrons inside the material that they can move around inside the material. So that's the difference between the conductors and the insulators. Insulators, electrons are bounded to the atoms and molecules. They can't move around. They cannot go hop to another one. But conductors have a free electrons that they can move around in the materials. Let me show you the slide again. So here, different materials hold electrons differently. Insulators, both have electrons, insulators or conductors, but the insulators' electrons do not move around freely inside. And plastic, glass, cloth, any cloth, fabric, wood, rubber, paper, they're all insulators. Yeah, conductors though, inside the conductors, you have free electrons. Electrons can move around freely inside the materials, and the metals are conductors. So silver, gold, copper, aluminum, these are all conductors. So conductor means free electrons. Insulators means electrons are tightly bounded to the nucleus. And there are other kind of materials. So semiconductors, you might have heard the word like a semiconductors. They have a property that's both, it can be a conductor, it can be an insulator, depends on the situation. So we use this property sometimes to change, to make it conductive or non-conductive. How we can so the semiconductors, how they can be changed by adding some impurities in it. You add more impurities, the material becomes conductive. More pure, it becomes more insulator. So you can change that, which is called electric resistivity. So that insulators have a higher electric resistance, its resistance, and conductors has a very low electrical resistance. So the semiconductors can change its material's electrical resistance by doping. Or some of the semiconductors' electric property can be changed by thermal. So in higher temperature, it can be insulator, and a lower temperature, it can be insulator. Or in you have the semiconducting material, and you shine the laser light at one spot, and then only the spot that's being shone by the laser light becomes conductive, and then everywhere else can stay insulator. So you can even like a pattern the wire, like a pattern, right? You can draw a circuit by the laser, pattern it, and then that can act like a wire. For the some semiconductors can be changed, the electrical property can be changed by the light. So depends on the type of semiconductors. You can do it by thermally, temperature, or doping, impurities, and things. So that's semiconductors. You might have also heard of a word like a superconductors. So I mentioned that materials, depends on the materials, you may have a different kind of electrical resistance, right? The conductors typically have a low electrical resistance, and insulator have a high electrical resistance. Superconductors have a zero electric resistance, which means that once, let's say you have a flow of electrons established, it's going to keep going forever, no resistance. So once you have a flow of electrons in a superconductors, it's never going to dissipate it. It just keeps going, going, going. And that's called superconductors. So you have no loss of heat by heat energy, no loss, and zero electrical resistance. And that's the superconductors. All right. So here again, but most importantly, I want you to know that insulators have electrons that cannot move around. Conductors have a free electrons. The electron can move around inside. And if you hear material like a metals, you should know that they're conductors. Papers, plastic, wall or wood and dry air, they are insulators. All right, so this is the end of this video. I'm just introducing you different types of electric property of material. See you at the discussion.